Good day, everyone. I'm Evan Claire Mandasa from BSECE 3B, and now I will perform my performance number 6 entitled Convolutional Code in ECE 23. Convolutional code is a type of error-correcting code that generates parity symbols. Instead of transmitting the original data, we are transmitting parity symbols. Convolutional codes were introduced in 1955 by Peter Elias. So I have here an example diagram which is a convolutional coder rate of 1 over 3. The rate of this convolutional stabilizer code is in quantum terms, which is also 1 over 3. The code encodes 1 qubit stream into a second stream at a rate of 3 qubits per original qubit. Now, we will determine the output bits for N1, N2, and N3. The operation we have here is XOR. We will perform a logical XOR between the bits in our system. You can see in the diagram that it has standard 2 bits, and these bits are constructed using shift register. The bits are shifted to the right, so this is shift right register. There are 2 bits in our state. Based on the transition table, we can determine the next state. I have here 4 possible combinations. To find the value of N1, input XOR to M0, XOR to M negative 1. For the N2, M0 XOR to M negative 1. For N3, input XOR to M negative 1. So, the output for input 0 is 0, 0, 0. And next, for the input 1, we have output 1, 0, 1. Input 0, we have output 1, 1, 0, and so on. As a result, the next state is equal to 0 for the first input, which is 0, 1 for the second input, which is 1, 0 for the third input, which is 0, and so on. The input are in parity symbols. Parity serves as a form of error checking if the inputs are encoded correctly. Now that we have a transition table, we can determine the state machine diagram. In that transition table, we have 4 states. The number of circles will depend on the number of states. The circles are labeled according to each state. Changes in state will be represented by arrows. So we have 0 over 0, 0, 0, 1 over 1, 0, 1, 1, 0 over 0, 1, 0, and so on. 0 is for the input. Over 0, 0, 0 is the output. Same goes to other, which are 1 over 1, 0, 1, 1 over 0, 1, 1, and so on. Every input and every state must be put in the state diagram. To transform our state diagram into trellis diagram, put the states in a vertical column and with corresponding states label. In trellis diagram, we are combining transition diagram with state diagram. The first column is the previous state, and the next column is the next period. Now we will interpret the arrows in the state diagram and transfer it into trellis diagram. We have here and its values. The basic underlying idea of trellis-coded modulation is to use convolutional code to generate the redundancy necessary to achieve a coding gain, while preventing bandwidth expansion by increasing the size of the cancellation rather than the number of transmitted symbols. So that would be all. Thank you and keep safe.